Hello everyone, my name is Tobias Kreklo and I'm the CEO and one of the co-founder of Hype Solutions. Today I would like to introduce you to our German startup. We are based in Hanover and we develop and manufacture hyperspectral imaging solutions to look beyond the visible of the human eye. Everyone is probably familiar with these images nowadays and knows that we cannot continue to deal with our planet in the same way as before. This is one of the reasons why we, as a team at Hype Solutions, are committed to using technology for a meaningful purpose. We are now developing products for very different applications in what we call the environmental sector. This ranges from agriculture and forestry to the food industry, environmental monitoring and recycling. Since this event is about digital technologies for sustainable crop production, I will focus more on agricultural applications during this presentation. Precision farming and the precise application of pesticides or fertilizers is seen as part of future-oriented agriculture. However, the information for precision farming applications has to come from somewhere, in many cases via sensors, for example. Our technology can also be located in this area, but in order to better understand what hyperspectral technology actually is, let's take a short excursion into the basics of electromagnetic radiation. The reflection of electromagnetic radiation is related to the chemical and physical properties of the reflecting surface and the layers underneath. Spectroscopy, as well as the eyes of humans and animals, makes use of this fact to classify, an example, evaluate objects. From the reflections in different wavelength ranges, a conclusion can be drawn about the quality of a substance or the quantity of one of its components. The human eye is limited in its spectral bandwidth to the range of visible light from 400 to, for example, 750 nanometers. In contrast to the human eye, spectral sensors have the advantage that reflections can be recorded reproducibly and objectively. In addition, they usually have a larger spectral bandwidth and then, in the longer wavelength range, also record reflections in the near infrared and also short-wave infrared. On the Earth's surface, radiation interacts with an object and is partially absorbed, reflected, and in the case of non-transparent objects, transmitted. The proportions of absorbed, transmitted, and/or reflected radiation vary according to the material and wavelength, which is the basis for remote sensing applications. Hyperspectral images can be displayed in so-called data cubes. These three-dimensional structures consist of two spatial dimensions, x and y, and a spectral dimension, z. Each image pixel contains spectral information about the measured wavelength range. In this example on the right, you can see the reflection of barley leaves with varying degrees of rust. Vegetation, for example, reflects light differently depending on the amount of stress, which makes it possible to distinguish between different stress factors that would be impossible or very difficult to detect with the human eye. In the part of the light visible to humans, it is particularly the leaf pigments in which changes can be detected, but areas of the near-infrared are in turn influenced by cell structures, for example. Depending on the parameter or type of stress, the effect on the spectral signature changes, and thus more in-depth analysis can be carried out. Hype Solutions has now developed an entire product portfolio around environmental use cases. This ranges from stationary solutions to handheld devices and user-friendly solutions on the drone. I would now like to take a closer look at two products, as these are certainly the most interesting for the use in the field. First, I would like to start with our product Blackbird, which is a hyperspectral camera specifically designed for drones of the DJI Matrice 200 and 300 series. The camera is based on a line scanner but can perform the movement internally when the drone is in hover mode, so external movement by the drone is not necessary. The camera can be operated like a DJI payload, so it is also possible for inexperienced people to use this camera easily on a drone. In the future, there will be also a reference sensor that will enable automatic referencing of the images with the ambient light and works with the same accuracy as the hyperspectral camera. A big advantage of the DJI Matrice 200 and 300 series is also the possibility to combine different payloads with each other and therefore also to enable sensor data fusion, for example. There's now a whole range of different payloads available, from high-resolution RGB cameras, thermal cameras, or even LiDAR sensors. Another fairly new developed product of ours is the Black Mobile camera, a handheld hyperspectral camera with integrated broadband LED illumination. For the first time, it is now possible to make mobile measurements independent of the lighting. The large touchscreen display on the front allows easy input for the user, and the integrated GPU can already enable initial pre-processing or analysis directly on the device. Our team has a very broad expertise in different areas, from software to optical technologies, mechatronics, and finally, for me, the connection between technology and practice. I studied originally physical geography and landscape ecology. That enables me to make a good connection between the requirements of the user and the technology we offer. That's it so far from my side. If there are any questions, I'm happy to answer them. Otherwise, please take a look at our website or send us an email. Thanks a lot for your attention.